Okay, the next kind of table we're going to talk about is what you see at the top of the screen. It's called a two-way frequency table. And the reason it's called a two-way frequency table is it tells you about two sets of information. Right, so if we look at this table right here, not even reading the question yet, but if we just look at this table, and we kind of read the headings, we can see we have male and female. So that's a set of information. And we also have extracurricular activities or people that don't do extracurricular activities. So that's why it's a two-way frequency table. It tells you about two sets of information. And so the way you read this, if you are talking about the number of males, this whole is males. So the male total would be the 257. So you could put a little m by that if you wanted. That's the male total. And then if you wanted to talk about females, you would look at this kind of middle row of the table. So this whole row is about females. So that 259, that's the female total. Okay. The other way is you can look down the columns instead of across the rows. So if we look down this first column, these are all the people that are involved in extracurricular activities at school, like band or football or baseball or basketball or softball or drama, whatever. Those are your extracurricular activities. So this total down here, this would be the total of people that are involved in extracurriculars. And then if we look at the middle column, these are the people that are not involved in extracurriculars, and this would be that total. And then let's see, in this bottom corner, this is the total of everyone in the table. So this is the like big total, the final total. That's the everybody total. Okay. And so if we read our little question, it says, what is the probability that a randomly chosen student is a female who is not involved in extracurricular activities? So this is going to be out of everyone. So our answer is going to be out of 516 because that's the total. So we want to find in this table the number that represents the females that are not in extracurricular activities. So what we need to do is we need to find the female row, that's this one, and we need to find the not involved in extracurricular activities column, that's this one. And the place where those two things come together is the thing we're looking for. So we're actually looking at this number right here, 120. That is the females. That's the people that fall in the female column and also, or the female group, and also fall in the not involved in extracurricular activities group. So our answer is going to be 120 out of 516. Both of those are even numbers, so at the very least you can divide them by 2 to reduce your fraction. And when you do that, you get 60 over 258. Those are both even, so you could divide both of those by 2 again, or you could just do 60 divided by 258, which is 0.2326-ish. I'm rounding. So that's about 23%. So the probability that a randomly chosen student is a female who's not in extracurricular activities is about 23%. Okay, so that's how you use the table. Let's look at this little example down here about prom. Okay, so this one says the two-way frequency table at the right shows the number of male and female students by grade level on the prom committee. So we have a male column that's this way, we have female column in the middle, and then we have a row of juniors going this way and a row of seniors going this way. So my big total is 12. Okay, So it says, what is the probability that a member of the prom committee is a male who is a junior? So this is going to be out of 12 because there are 12 total people on the prom committee. So what we need to do is we're interested in males and juniors. So we're going to look at the column for males and the row for juniors. And the number that is in both of those, that 3 right there, that's how many junior males are on prom committee. So our number is going to be 3 out of 12, which is 1/4, which is the same as 0.25, which is 25%. However you want to write that is fine with me. Okay. So there you go. And the reason we do these two-way frequency tables is to help us with this thing called conditional probability right here. And you can read, it says, that's the probability that an event will occur given something else already happened. Okay. So an example would be like talking about the probability that you pass geometry given that you did all your work, right? Normally to pass, you have to do work, so that's a conditional thing. Okay, so here's how you write this. Let's just say you have two things, A and B. There should be a line right there. Here's how you write it. It's P for probability, and then your little parentheses, B, and then a line, A. So this first thing, this is what you want to know about. And then this A this is what you already know. So this is the thing that's going to be given to you. This is something that you already know. Okay. And we're going to do some of these with a table also. Okay. So let's look down at this table. So it says respondents of a poll were asked whether they were for, against, or had no opinion about a bill about increasing minimum wage. It says, what is the probability that a randomly selected person is over 60 years old, given the person had no opinion about the bill? So we want to know, it says, what's the probability? So probability that a person is over 60. And then it says given. Given is where I put that line right there. So given they had no opinion about the bill. Okay. So I'm going to say given no opinion. So we want to know how many of them were over 60. We know for sure, the other way you can think about conditional probability is thinking the second thing, that's what you know for sure. So we want to know about the over 60 people. And we know for sure that they had no opinion. And here's what this means for us. If we know for sure they had no opinion, then the no opinion part of this table, this is the only part we have to look at. We don't have to look at anything else. We don't need this. We don't need this. If we know they came from the no opinion group, then we don't have to look at anybody except the no opinion group. Okay, so now when we do this, our total isn't going to be that number at the bottom, because that includes everybody. All we care about are these no opinion people. So now our total is only going to be 100. So it's going to be some number out of 100. And we want, in this little column of no opinion people, we want the group that's over 60. That's that 40 number. So our answer is 40 out of 100, which is 40%. So if we know for sure that they had no opinion, there is a 40% chance that the person was 60. Okay, we're going to do another one of those because I know that's kind of hard to think about. Okay, so we're going to keep looking at this table about the bill. We're just going to answer some other questions. Okay, so part A of this says, what's the probability that a randomly selected person is 35 to 45, given that the person is in favor of the bill? So we know, because it says it after given they're in favor. So this time, the only column we care about is this in favor column, which is the 4 column. So now our total is going to be 780. So this is going to be some number out of 780, and all we care about is the 30 to 45 range. So we find the 30 to 45, that's 200. So our number is 200 out of 780, which you could type in your calculator and figure out the decimal or percent. I'm just going to leave it like that. Part B said, what is the probability that a randomly selected person is not 18 to 29, given that they are in favor of the minimum wage bill? So we're still looking in this 4 column. Okay. So our total is going to be out of 780 again. And we're looking for the probability that they are not 18 to 29. So what that means is we want everybody except for the 18 to 29 group. So we want all of these people. So we just need to add those together. So 200, 120, 50. Oh, 200, 120, 150 is what? 470 out of 780. Again, you could type that in your calculator and get a decimal if you wanted to, or a percentage. The other way to do that would be to look at it and say, well, 310 of them are 18 to 29. So if you do 780 minus, oops, 780 minus 310, that gives you the 470 that we came up with. Okay. We're going to do one more. Let's see. Let me find a good one. We're going to do, so now we're going to do this one. This is about attendance at a soccer camp. So in this table, we have our information broken down in terms of girls and boys, and we have 6th, 7th, or 8th graders. Okay. So we're going to look at, let's see. This first one we're going to do, it says P for probability, girl. So we want to talk about the girls. It says given, so this is what we know for sure. We know we're in the 7th grade, okay? Which means the only column we're going to look at is the 7th grade column. So your total is going to be 13, so this is going to be some number out of 13. And of those 13, which ones are girls? Find the girl row, there's a 7, so 7 out of 13, okay? This next one says we want to know about 6th grade, and we know for sure they're a boy. So if we know for sure this person is a boy, all we're looking at is the boy row. That total is 23. Okay, so our total is going to be 23. And then all we care about of the boys, of those 23, we only care about the 6th graders. There are 7 of them. So 7 out of 23. And then this last one, we want to know the probability that you're in 8th grade if we know for sure you're a girl. Okay, so let's see. We're going to only look at the girl row. That total is 27. And we want to talk about just the 8th graders. So of those 27 girls, how many of them are 8th graders? There they are, 12. So 12 out of 27. Okay. And we use them for this conditional probability where you know the second thing, whatever it is, that's what you know is true. So when you see these things written out, you have a probability of something you want to know about. And then after this line, there will be something, and this is what you already know for sure. This is what you're already sure about. So this tells you what group to look at. And then this tells you what part of that group you want to know about.